Welcome back. We are now entering the critical phase where plans and code become reality. Information systems implementation. This isn't just about switching it on. It involves a complex orchestration of moving systems, deploying infrastructure, and converting data. We will explore how to move from a legacy environment to a new solution without breaking the business. Let's get started. Let's begin with the big picture. Information systems implementation is the bridge between a developed product and a live business tool. As defined in our sources, it's the process of ensuring a system is operational. It's not a single event, but a phase that includes three massive pillars we will dissect today: system migration, moving the logic; infrastructure deployment, building the home; and data conversion, moving the memories. Your goal as an auditor or manager is to verify readiness. If you flip the switch before the infrastructure is stable or the data is clean, you don't just have a glitch, you have a business stoppage. This flowchart visualizes the implementation phase as a central hub. We receive the output from development or acquisition on the left. We then split into three parallel, interdependent workstreams: infrastructure deployment, data conversion, and system migration. Only when all three converge successfully can we move to the final state on the right: go live in operations. If any branch fails, the path to operations is blocked. How do we actually move? We have to choose a migration strategy, often called a changeover technique. You have four main choices. First, the abrupt or direct cutover. You turn off the old and turn on the new. It's cheap but risky. If it fails, you are dead in the water. Second is parallel changeover. You run both systems at once. This is the safest route, because you have a fallback, but it's expensive and doubles the workload. Third is phased. You move one piece at a time, perhaps by module or branch office. Finally, there is the pilot approach. You test the waters in one department before committing the whole ship. The choice depends on your risk appetite and budget. Before the software can run, it needs a place to live. This is infrastructure deployment. In the modern era, this often means cloud computing. You need to understand the service models defined in our text. IaaS gives you the raw building blocks, servers, and storage, but you must patch the OS. PaaS gives you a platform to build on, handling the OS for you. SaaS is the full package. Think Google Docs or Zoom, where you just log in and work. We also use virtualization and containerization to bundle applications with everything they need to run, ensuring that if it works on the developer's laptop, it works in production. This diagram stacks the responsibilities. At the bottom with IaaS, you see the user manages a lot: applications, data, and the OS. Moving up to PaaS, the provider takes over the OS, leaving you with just apps and data. At the top with SaaS, the provider manages everything. Understanding where the line is drawn is critical for security and maintenance planning. Now we address data conversion, often the riskiest part of implementation. We use a process called ETL: extract, transform, and load. First, we extract data from the legacy system. Then, crucially, we transform it. This isn't just reformatting. It involves data scrubbing. We must clean the data, because loading garbage data into a new system destroys its value immediately. Finally, we load it into the new database. This requires strict mapping rules. If the old system had a field for name, and the new one separates first and last, your transformation logic must handle that split perfectly. Follow the data in this flow. It leaves the legacy DB and enters a staging area. It hits the transformation logic diamond. This is where the magic happens. We scrub and clean it. If it passes, it becomes clean data and is loaded into the new system. If it fails validation, say, a date format is wrong, it is kicked out to an exception report for manual review. We never load bad data. Data conversion isn't just moving files, it's about integrity. We apply input validation to ensure that if a field expects a date, it gets a date, not a text string. We must have robust error handling. If a record fails validation, does the whole batch fail, or do we log it and continue? We also look for mapping controls. You'd be surprised how often a social security number ends up in a phone number field without proper mapping. We rely on the ACID model atomicity, consistency, isolation, durability, to ensure that transactions are processed reliably. Without these controls, your new system starts its life corrupted. Here's the life cycle of a single data record during conversion. It enters as input data. It hits the validation check. If valid, it travels the accepted path to the database and gets logged in the audit trail. If invalid, it goes to rejected, enters the error log, and moves to a correction queue. Notice the loop: it goes back to input data after correction. This ensures nothing is lost, only fixed. Implementation is a massive change event, so it requires strict change management. You cannot just wing it. You need a formal request and approval. The most critical component here is the rollback strategy. If you flip the switch and the new system crashes, Can you go back to the old one? If not, you have violated a core principle of deployment. We also focus on scheduling doing the cutover when it hurts the least, like 2 a.m. on a Sunday. And don't forget the humans. User training must happen before the cutover, not after they start calling the help desk in panic. This sequence shows the drama of cutover. Change management gives the go. Operations first backs up the legacy system. That's your safety net. They execute deployment. Now look at the fork. If it fails, they immediately trigger rollback. If it succeeds, they enable access for users. Only after users confirm it works do we close the ticket. The rollback path is the most critical safety feature here. Before we go live, we test. We don't just check if it turns on. We use user acceptance testing, UAT, to let the actual business users verify it handles their daily tasks. We use regression testing to ensure that fixing one bug didn't create 2 new ones. If we are doing a parallel migration, we perform parallel testing, comparing the output of the old system to the new one to ensure they match perfectly. Finally, we have certification and accreditation. Certification is the technical sign-off that it works. Accreditation is the management sign-off that they accept the risk and authorize production use. This diagram structures the testing hierarchy. We start with the technical testing phase class unit, system, regression. If that passes, we promote to the UAT class, where users run business scenarios. If they sign off, we move to the go-live decision class. This is where certification, technical, and accreditation management happen. It's a gated process. You can't jump to go live without passing UAT. We aren't done when the system goes live. We enter the post-implementation phase. We conduct a review, PIR, to ask, did we get the ROI we expected? Did we meet the business needs? We document lessons learned. And finally, we must handle the ghost of the system past, disposal. We don't just throw old servers in the trash. We perform media sanitization overwriting, or physically destroying drives, to ensure sensitive data doesn't leak. Only then is the implementation truly complete. Our final journey. We start at go live. We enter stabilization fixing early bugs. Then we hold the post-implementation review. This splits into checking ROI and gathering lessons learned. These inputs lead us to the final act, system disposal and sanitization of the old gear. Finally, we reach project closure. The cycle is complete.